Now we are going to start with the MCQ of the fourth chapter. So here you can see question number one. The graph shows how the length of the string changes when the stretching force is increased. And you can see this graph. The y-axis is given is the length, and the x-axis is given in the force. In the Hooke's law region, what is the spring constant for the spring? So we want to find out what is the spring constant. So here I have attached the formula of the Hooke's law. We have learned the Hooke's law, what happens when we attach this the mass to the spring at the bottom. What will happen? The spring will extend, and the force that we are attaching at the bottom is directly proportional to the extension. So we have seen this force is directly proportional to extension in case of the Hooke's law. Okay, so here from this formula we know what is the spring constant is nothing but spring constant is coming out to be F divided by x. F divided by x. If I take this x to the left hand side, this will go into the denominator. So F divided by x is nothing but the spring constant. Okay. So this graph, you can see the graph, the y-axis is length, x-axis is nothing but the force, and we know that this when the force is directly proportional to x, they are directly proportional to each other. That means there is a straight line. Either x is proportional to f or f is proportional to x. That is nothing but the same thing, and we get the straight line in that case. So we can see up to this line. I will mark this with another color. Up to this point, okay, from this initial point to this end point, there is a this is the region of Hooke's law, because this is a straight line. That means force and this force and the extension length are directly proportional to each other. Okay, so how we can find out this spring constant? Spring constant is what? It is nothing but force divided by the extension. Okay, so we can find out that with the help of the concept that is nothing but the slope. Slope is what? Y2 minus y1 divided by x2 minus x1. That is nothing but change in the y-axis divided by change in the x-axis. So we can find out the slope, and for this particular length we can find out the slope, and I'm selecting here 2 points, initial point with the red color, final point with the red color. So I will mark here the triangle basically. So this can be the triangle, and with the help of this triangle, using this triangle thing, we can find out what is the slope. Okay, so here you can see what is the change in the y-axis. Change in the y-axis, on the y-axis the final point is 20, initial point is nothing but 5, so I can write 20 minus 5, and on the x-axis you can see this is the final point is 5, initial point is nothing but 0, so it is 5 minus 0. So we are getting the value of 15 divided by 5. That is nothing but the slope, which is nothing but 3. So here what is the y-axis? Y-axis is nothing but the length. Okay, I can express that with the letter x, and x-axis is nothing but the force. So the slope is our x divided by force is nothing but 3. And what is the spring constant? It is a F divided by x. So this should be equal to reciprocal of the spring constant. Okay, this should be equal to reciprocal of the spring constant, because spring constant from the formula is x divided by x, F divided by x, and from this slope we are getting x divided by f. So it should be reciprocal. They are reciprocal to each other, so it should be 1 by k. So k value, if I do the reciprocate of 3, reciprocal of 3, I will get 1 by 3. That is coming out to be 0.33. Okay, the 3 is recurring over here, so we can find out recurring t. We can say recurring 3 or 0.33. So this is the value of the k, and you can see in the options, D is the option where we are getting the value of 0.33. The unit is Newton by centimeter, because this is given in centimeter. This is the Newton. K is F divided by x. F is nothing but Newton. X is nothing but centimeter. So unit is Newton by centimeter. So you have to calculate the slope of this line. Okay, then you will get the value of the x by f. We have to do the reciprocal of that. Then you will get the value of k. Suppose if they give this as a force, y-axis as a force, and x-axis they give as a extension, then directly we will get the slope is equal to f divided by x, there is no need to do the reciprocal things. Okay, but they have given x divided by x, so we have to do the reciprocal of the slope to find out the force constant k. Okay, I hope you understood this problem. Now we will see the second problem. Which combination of the forces produces a resultant force acting towards the right? Okay. We want the resultant force acting towards the right. That means the force acting towards the right hand should be more than the force acting in a left hand. Okay. So force acting on the right hand should be more than the force acting in the left hand. So here in the option number 1, you can see this is 10 Newton is acting towards the left side, and here this is 5 plus 2 forces are acting, so 7 Newton is acting in a right hand direction. So you can see the 7 is less than 10, so it should move towards the overall force will be in the left hand direction, or we can say resultant force is in the left hand direction. In this case it is 4 plus 3, that is nothing but the 7 Newton. So this we can say is our option, because resultant force is what? Resultant force will be 7 minus 5, that is 2 Newton should be in the right hand direction, because here right hand force is greater than the left hand force. So option number B is right. Here you can see 6 plus 4, 10 Newton is in the left hand direction, 10 Newton in the right hand direction. So resultant force will be equal to 0, because they are equal and opposite. Here you can see this is 5 plus 3, it is 8 Newton in the left hand direction, and right hand direction it is 7. So you can see here left hand direction force is greater than right hand direction, so it will also move towards the left hand direction. So option number B is only the correct one. Okay, one direction you can consider positive, another direction you can consider negative to find out the resultant force. Okay, here we need to just find out which direction the resultant force will act. Okay. So here option number B is the correct. Now question number 3. The weights of 4 objects 1 to 4 are compared using a balance of which object is the lightest. So you can see here the balance, 3 balances are here, and the weights are kept on this pans. And here here is the importance of the moment formula. So I'll write down here what is the moment formula. We know that moment is nothing but equal to force multiplied by the perpendicular distance. Okay, that is the formula of the moment. So in this case you can see these balances are this weights are kept on these spans, and you can see this middle one is nothing but the pivot. This one is the pivot, this one is the pivot, this one is the pivot, and you can see these are the attachments. These are the attachments here, and this distance of these attachments from the pivot is constant. Okay, and that's why we can directly see the level of the objects to identify which object is heavier or lighter. Okay, if suppose these distances are not equal, okay, these distances are not equal, then definitely only the level or position of these objects are not sufficient to identify whether these objects are lighter or heavier, because we are considering here the moment formula. Not only the weight or mass is important, but the moment is important. Moment is nothing but force multiplied by perpendicular distance. Here no distance is perpendicular, because all the this horizontal attachments are inclined, though those are not exactly horizontal. But since the distances from these attachments are equal, we can consider directly the objects, the level of the objects which are kept in the pan. So here in the first balance you can see the weight 1 is below and weight 2 is above. So definitely weight 2 is nothing but smaller than 1. Here also weight 2 is above and weight 3 is below, therefore 2 is definitely smaller than, or you can say lighter than 3. Okay. But here you can see from this we have observed that 2 is lighter than 1, 2 is also lighter than 3. But from this you can see weight 4 is above, weight 2 is below, and 4 is still even lighter than 4. So we can say the lightest weight is nothing but weight 4. So option number D is our answer. Okay, so I hope you understood. Here the moment formula is used Since R here, this R is constant almost constant, not exactly. That's why we can focus only on this force. Force is nothing but this weight and the level of weight to identify which object is lightest or heaviest. Now the question number 4. Three horizontal forces act on a car that is moving along the straight level road. You can see the air resistance is there, friction is there, and the driving force is there. Driving force is nothing but the force exerted by the engine, okay, which drives the car. Which combination of the forces would result in the car moving at constant speed? So this whenever we get the constant speed, okay, if we get the constant speed, okay, suppose if we have the constant speed, it means that it means that there should be the acceleration which is equal to 0. So I can write it implies that acceleration should be equal to 0, and since the acceleration is equal to 0, that means the force is also equal to 0. Force is equal to 0 means what? What is the meaning of this thing? Force is equal to 0, that means force is nothing but balanced force. You can say force is nothing but balanced force. So this is a sequence, we should know this sequence. The force is nothing but balanced. So if the speed is constant, that means acceleration should be 0. If acceleration is 0, force is what? Force is nothing but mass into acceleration. Acceleration is 0, that means force is also 0. And 0 force is, we call it as balance force. So when we get the balance force, when there are equal and opposite forces are acting in opposite direction. Okay. So which option will give such kind of result here? Air resistance is 200 and friction is 1000. So total will be 1200 here on the left hand side, and right hand side driving force we have only 800. So both are not equal. They are opposite in direction but not equal. So we can't get any balance situation. Option number B here, friction is air resistance is, that is nothing but the air friction, that is nothing but 800 here. This friction to the floor is 1000. The total force in the left hand direction we can say 1800, but driving force is only 200 Newton. So that is also not possible. It is not balanced situation. Option number C, the air resistance is 800 Newton, friction is 200, so total is 1000, and driving force is also 1000. So we can say they are equal and opposite, equal in magnitude, opposite in direction. Okay, so that's why we get the balance force situation. Balance force situation, that means acceleration is 0 and speed can be constant. So option number C is only the answer. D option number, you can see 1000, air resistance, friction is 200, so total is 1200, and driving force is only 800. So this is also not possible. They are not equal and opposite. So option number C is only the correct option. Then question number 5, which property of object cannot be changed by the force? Okay, we know that force is nothing but mass into acceleration, and we know that force can change the motion, that means it can change the speed, it can change the direction, that means combinedly it can change the velocity. It can also change the speed, it can also change the size in case of the object can be compressed or extended or expanded. Okay. But mass is the thing which cannot be changed by the force. Force is nothing but mass into acceleration. If acceleration is varied, force can be varied, but mass remains the same. If you know the difference between the weight and mass, okay, mass also always remains the same, but force can be different, because weight is nothing but the force. Weight can also be different if gravity is changed. Weight can also be changed, but the force solely depend on acceleration. So mass is always the constant. It cannot be changed by the force. Force can change motion, shape and size, but not the mass. So option number A is correct. Now we will see the structure problems. Now we will start with the structure problems in a course. So you can read here question number 1. Figure 2.1 shows a sign that extends over a road, and the mass of the sign is given, that is nothing but 3.4 into 10 raised to 3 kilogram. So you can see this sign is here. This sign is showing the accident slow down, and there is a support rod here, support post is there, and this is the additional support to the left hand side, which is nothing but the concrete block. And we need to find out the weight of this signboard that is showing the accident slowdown. And the mass is given, that is 3.4 into 10 to the 3 kilogram. So we need to find out the weight, and weight is nothing but the gravitational force which is acting on the object. So that is nothing but mass into gravitational acceleration. So here we can write 3.4 into 10 raised to 3, that is nothing but the mass of the object multiplied by the acceleration due to gravity. So you can write down acceleration due to gravity. The rough value is nothing but 10. So here the value is coming out to be 3.4 into 10 raised to 3 into 10 is nothing but 3.4 into 10 raised to 4. Okay, so this is the value of the weight, and weight is nothing but the force, so it should be measured in the Newton. Okay, so here also we should write down 3.4 into 10 raised to 4 Newton. This is nothing but power here. So the weight of the object is 3.4 into 10 raised to 4 Newton. Then B part of the question, the weight of the sign acts on the horizontal distance at the horizontal distance of 1.8 meter from the center of the support post, and it produces the turning effect. It produces the turning effect about a point P. Okay, so whenever there is a turning effect, it is a question of the moment. Okay, the point P is the horizontal distance, of 1.3 meter from the center of support post. Okay, so here you can see this is a point, and it is at the 1.3 meter from this center of the support post. Okay, so this distance is nothing but the 1.3. And this is the weight of the object. It is shown that weight of the object is acting exactly at the center of this signboard. So we can see weight we always show to act through the center of mass, and center of mass of this kind of symmetric body is the center of the body itself. So that's why the weight is shown to be acting through the middle of the signboard, because we can consider at the middle only there is somewhere the center of mass, and it is acting always in the downward direction. And the weight, this point of weight is nothing but at the distance of 1.8 meter from the center of the this support post. We need to find out the moment about the point P. We need to find out the moment about the point P. So we need to find out this distance. Okay. Okay. So this is just point P, just like the pivot, and weight is just like the force. Now let's see what is the question here. Calculate the moment of point P due to the weight of the signboard. Okay, so we want to calculate the moment basically about this point. So this is like a pivot, and the weight is just like the force. We want to calculate the moment of this weight about the point P, and that's why we need a distance of this weight, okay, weight line from the point P. So we need basically this distance. We need basically this distance. This distance we need the distance of this weight from the point P. So how much is distance? We can see this is nothing but this 1.8 minus this 1.3. That's why then we will get this distance of this weight line from this point P. So the formula of the moment is written over here. Moment is force multiplied by d, that is the distance. So d is the perpendicular distance of the force from the point of interest. So here weight is, I told you the weight is just like a force, and the distance of this force from this point P is nothing but this, that is 1.8 minus 1.3. So here we can calculate the moment here. Moment is nothing but, we can write down capital L for moment. Moment is nothing but force multiplied by that distance, that is nothing but specific distance which is perpendicular to the force. force. So weight is how much weight is nothing but we have just calculated in our question A. Weight is nothing but 3.4 into 10 raised to 4 Newton. Okay, so this is the value of the weight. And what is the perpendicular distance? We had just seen it should be equal to 1.8 minus 1.3. Should be equal to minus, right? It should be equal to 1.8 minus 1.3. Okay, so here we can write down it is 3.4 into 10 raised to 4, 10 raised to 4, and 1.8 minus 1.3 is nothing but 0.50. Okay, multiplied by 0.50. Okay, so here calculation of this 3.4 into 10 raised to 4 into 0.5 is giving us the value of 1.7 into 10 raised to 4. So this is our value. Okay, this is our final value, and the unit of this moment is nothing but Newton into meter. Newton into meter. So here also we can write down the final value, that is 1.7 into 10 raised to 4, and the unit as well, that is nothing but Newton meter. So here writing down the answer here is very important, otherwise you may lose 1 mark, and writing down the answer along with the unit is very important. Now you can see here second question. A concrete block is positioned on the other side of the support post with its center of mass at a horizontal distance of 70 cm from the center of the support post. So here you can see this concrete block is kept on the left hand side, and the center of mass of this concrete block, and that is nothing but, you can see here it could be the center of mass of this concrete block, and the center of mass is at the distance of 70 cm from the center of this support post. Okay, so state what is meant by the center of mass. What is the meaning of the center of mass? It is nothing but the point where the all the mass of the body can be considered to be concentrated. Okay, so you can write down here. It is the point where whole mass of the body is supposed to be concentrated. Okay, so this is the one point where we can say whole mass of the body is concentrated, and if you apply the force to that particular point, entire body will move in the straight line. So that is nothing but the center of mass. All symmetric bodies, for all the symmetric bodies, the center of mass is nothing but its geometric center only. Okay, so here you can see question number sub question number 2. The weight of the concrete block produces the moment here about a point P that exactly cancels the moment caused by the weight W. Okay. Calculate the weight of the concrete block. Okay. So here you can see the moment produced by the weight about a point P is exactly the same as the moment produced by this concrete block about the point P. Okay, so that is nothing but called as the principle of moment. So this is the principle of moment is F1 d1 is equal to F2 d2. Here this is a pivot, and at this point this is a rod. You can say the rod distance of this extreme point of the rod from the pivot is d1, and at this point force F1 is acting. On the another extreme, force F2 is acting here, and distance of that extreme point from the pivot is d2. So here F1 into d1 should be equal to d2 into F2, so that this rod will be in the balance situation, and that we can say these two moments F1 d1 and F2 d2 are cancelling each other. So this is called as the equilibrium position. So in this case also the moment produced by the weight about point P is equal to the moment produced by this concrete block about point P, and that's why they can cancel each other, and that's why only this support post is not falling either on the right hand side and left hand side. It is exactly standing vertically constantly, because the moments are equal and opposite. So we can apply here this principle of moment, and we know that this weight, we know that the weight, the distance of this weight from the point P that we have already calculated. Now, and the distance of this concrete block from the point P is also given. We can calculate this distance. This distance we need to know to calculate the moment. This distance is how much? This is nothing but this 1.3 plus this 70 centimeter. Okay, that is nothing but 0.7 meter. And we need to find out what is the mass of this concrete block. So we will apply here the principle of moment. I will copy this equation directly over here. So this is nothing but F1 d1 is equal to F2 d2, where F1 is nothing but the weight of the concrete block, and we need to find out the weight only directly, and d1 is the distance of that concrete block from the point P, and here you can see this is nothing but 70 centimeter plus 1.3 meter. 70 centimeter is 0.7 meter and this is 1.3 meters, so this is the total distance. So we can write down over here. So I will write down weight for F1. F1 is nothing but the weight of the concrete block, and distance is nothing but 0.7 plus 1.3 is equal to nothing but here F2d2 is what is nothing but the moment of that weight signboard about point P that we have already calculated, and that is nothing but 1.7 into 10 raised to 4. So here we can calculate this remaining part. This is weight W multiplied by this 0.7 into 1.3, that is nothing but 2, that is equal to 1.7 into 10 raised to 4. 1.7 into 10 raised to 4. So here we can calculate what is the weight W. I will write down here this way. So weight W is nothing but here is equal to 1.7 into 10 raised to 4 divided by this 2. When this 2 will go to the right hand side, it will go into the denominator. So you will get the value of the W, that is the weight of the concrete block, is nothing but equal to it is coming out to be 8.5 into 10 raised to 3. 8.5 into 10 raised to 3. The unit is nothing but Newton. The unit of weight is Newton because that is nothing but the force itself. So this is the calculation part of the weight of the concrete block, and that is coming from this principle of moment, that is nothing but F1 d1 is equal to F2 d2. So we can write down this weight again over here, that is nothing but 8.5 into 10 raised to 3 Newton. Okay, so this is our sub question number 2. Now part C of the question, the concrete block is removed, the sign and the support post rotate about the point P in the clockwise direction. State and explain what happens to the moment about point P due to the weight of the sign as it rotates. So let's see what happens to the moment about point P due to the weight of the sign. So here you can see in the figure, if you remove this concrete block, what will happen? This entire signboard and this along with this support post this will fall in the right hand direction, or we can say in the clockwise direction. So we need to see what happens to the moment, and moment is nothing but, it is nothing but force multiplied by the perpendicular distance of the center of mass of this signboard from the point P. So let's think about the force first. Force is nothing but the weight of this signboard, and weight is nothing but mass into acceleration. Acceleration due to gravity. So mass, if you consider the mass of the signboard, the mass always remains constant. Wherever the object is, mass is always constant. Now the acceleration due to gravity is also constant near the surface of the earth. So if you see the multiplication of mass into acceleration due to gravity, that is nothing but the weight. Weight will always remain constant because this object is nearby the surface of the earth. So there will be no change in this force, because force is nothing but the weight. Now let's see what is the what happens to the r. R is what here? R is nothing but the distance of the center of mass from the point P, and that is the perpendicular distance. So first of all, we will see here. Suppose at the center here, I will assume that this is the center of mass only. So the center of the signboard itself is the center of mass because it is a symmetric body. So when this object will fall in this clockwise direction, this center of mass will also fall in this direction roughly. Okay. So here when the center of mass will fall in along this direction, I can consider these 2 points over here. Okay, and from this point, what will happen? The weight, we can see the weight is always acting in a downward direction. Anyway, the weight is always acting in a downward direction, and it is always constant near the surface of the earth. So r is what? R is the distance, perpendicular distance of this center of mass from the point P. Okay, r is what? Perpendicular distance of the center of mass from the point P. This line is showing you the the, the line along which the center of mass of this signboard will fall once we remove this concrete block. So what is the perpendicular distance from point P? So you can see here, if you consider this point, then you can say this is nothing but the perpendicular distance from the point P. Okay, this is the point P here. The point P line is nothing but this. Okay, and what is this line? This weight line, or we can say the line of action of the weight that is passing through this center of mass. Okay. So this you can say is the perpendicular distance from the point P. So it is you can say I have drawn here for this distance is perpendicular to the direction of the weight, because weight is always in the downward direction. If you consider this point of this fall line of the center of mass, then perpendicular distance will be equal to this. Okay, so you can see here, as the signboard will fall in this right hand direction or in the clockwise direction, the center of mass of this board will go away from this point P. If you consider the perpendicular distance from this weight, this is the weight which is falling in the downward direction. That's why I'm drawing only the perpendicular line and up to this line only, because at this line there is a point P. Okay, because r is what? R is nothing but the perpendicular distance from the pivot. P is like a pivot, and the weight is falling in a downward direction, so I should draw a line which is perpendicular to this weight. Weight is nothing but the force. So this line will increase. So there will be the increase in R. So that's why there will be the increase in the moment, because the force is remaining constant, because the weight is the constant. So here we can write down as the can write down here as the perpendicular distance between point P and the, you can write down line of action of weight. What is line of action of weight? That is nothing but the point where the we can say that is nothing but the center of mass. Okay, because the line of action of weight is passing always to the center of mass. So that line, that perpendicular distance, if it increases, then we can say the moment about the moment about point P will also increase. So moment is force multiplied by perpendicular distance. So force, that is weight, is constant, but the perpendicular distance from the line of action, you can see here the line of action, from the line of action of the weight will increase. What is the line of action from the weight? That is nothing from the center of mass, because the weight is always passing through this center of mass. Weight is always acting through this center of mass. Weight is acting is nothing but the line of action. Okay, so this you can say this vertical line that is showing the or downward direction line is nothing but the line of action. Okay, so the distance from this line of action towards the point P is nothing but r. So this is nothing but the r. Now we'll see the second question here. So figure 2.1 is a head-on view of the airliner flying at the constant speed. You can see this is flying at the constant speed in the circular horizontal path. This is very important. The center of the circle to the left of the diagram. So here question number A. On the figure 2.1, draw the resultant force acting on the airliner and explain your answer. So we need to draw the resultant force. What is the resultant force? It is nothing but the addition of the all the forces acting on the airliner or any object. Okay, so whatever forces are acting on any object, we have to add them, and whatever one single force we will get as a result is called as the resultant force. So first of all, see, you can see here the airliner is moving in the horizontal circular path. This circular word is very important here, because whenever any object moves in a circular path, there is a force which is acting on that object toward the center of the circle is called as the centrifugal force. Here you can see the reference diagram is attached over here. So this is a circle and this object is moving in a circular path like this way. You can say it is moving in a circular path. So you can consider any circular motion, like you can consider the earth is revolving around the sun, or the moon is revolving around the earth, or you can consider this is a stone which is attached to the string, and you are rotating that in a circular path. Okay, whenever there is a circular motion of any object, there must be the force which is called as the centrifugal force, and that centrifugal force always acts toward the center of the circle. Okay, so here you can say it is flying in a circular path. I can consider this is the like circle along which the airliner is flying in a circular path, and can consider here somewhere it is the center of that circle, imaginary circle. So this airliner should be acted upon by the force which is called as the centrifugal force, which is directed towards this center. Okay, so we have to draw this. I'm rubbing this line, and I'm drawing the one single line which is acting from the airliner towards the center of this imaginary circle. Okay, and we have to show the direction, because centripetal forces are always directed toward the center of this imaginary circle. Okay, so I hope you understood. There is some circle like this, and this is the center of that circle, and this resultant force is nothing but this centripetal force, which is addition of the all the forces which are acting on this object. Okay, once the object is moving in a circular path, there must be the centripetal force. And how we can explain this answer? We should write down over here. Since the airliner is moving along the circular path, it must be acted upon by the resultant force, that is nothing but the centripetal force, Okay. Centripetal force which is by default, acting, which is acting, or which is, you can say, directed towards the center of circle. Center of circle. So there must be the centripetal force. This word is extremely important here. It must be acted upon by the centripetal force, which is directed toward the center of the circle. So here you should write down the centripetal force instead of just the centripetal. Okay. Now the part B of the question. The weight of the airliner is 1.2 into 10 to the 6 Newton, and there is the aerodynamic lift force of 1.39 into 10 to the 6 Newton acting at 30 degrees to the left of the vertical. By drawing a scale vector diagram or otherwise show that resultant of this force is in the same direction as the resultant force you drew in part A. So here you can see either by using the vector diagram or by using the calculation. Otherwise, we can show this using the calculation. The resultant force is nothing but the resultant force which is acting in the same direction that we had seen. We had drawn here, which is directed toward the center of this imaginary circle, that is toward the left hand side. So we can do it in either way, either with mathematics or with the vector diagram. So here I will show how we can show it with the vector diagram. But before that, we need to know how we can identify or we can show the resultant force uh, in terms of the vector diagram. So for that, we can use either the triangle law or we can use the parallelogram law. So here you can see this is the triangle law of vector addition. It is called as the triangle law of vector addition, and this one is called as the parallelogram law of the vector addition. Okay, so using either triangle law or parallelogram law, we can show the resultant force vectorially. So first of all, you can see here we have the two forces acting over here, which are nothing but the two vectors. Force is nothing but the vector. So we have to apply the vector algebra. For that, we have two laws of vector addition: the triangle law of vector addition and the parallelogram law of vector addition. So here you can see this. Suppose here A is nothing but the vector and B is nothing but the vector, and we need to find out what is the A plus B. What is the A plus B? That is addition of the two vectors. Because resultant is what nothing. Resultant force is nothing but addition of the all the forces. Okay, and force is nothing but vector. So here we need to understand the vector diagram. So here, what is the vector? First of all, vector is this arrow is showing the direction of the vector, and this length of the vector shows the magnitude of the vector. That you should always remember. So length is showing the direction of the vector, and this arrow is showing the direction of the vector. So if there is a suppose two forces here, suppose this is a force of 1 Newton acting in the directed towards the right hand direction. If I want to show the force of 2 Newton, then what I should draw? I should draw the line double to this original line. Okay, this will be the 2 Newton. Okay, so this line is showing the magnitude of the vector. So if this is 1 Newton force, it is suppose 1.5 centimeter line, then it is a 2 Newton force, it should be the 3 centimeter line. Okay, so that line is showing the magnitude of the vector and arrow is showing the direction of the vector. So here you can see the vector A is drawn like, suppose it is directed towards the point B here. I will say this is the tail of the first vector and this is the head of the vector A. Okay, and here this is a vector B. I can say this point B is nothing but the tail of vector B, and C is nothing but the head of the vector B, because it is directed from point B to C. Okay, it is moving in this direction, B to C. It is moving from A to B. That's why it should be the tail of first vector, head of the first vector, and B point should be the tail of the first vector, and C point should be the head of the second vector. So when once you draw a vector like this and we are connecting here head and tail, we are connecting here head and tail of the two vectors. Okay, then we can consider this as the first side of the triangle, and here we can consider as the second side of the triangle. You have to just connect their head and tail, and then you have to just simply draw the third line. This will be automatically the addition of the two vectors. So here you can see it is nothing but the A plus B. Okay. So C is starting from the tail of first vector and ending at the head of the second vector. This direction is extremely important. You have to draw always from the tail of the first vector towards the head of the second vector. So this third line itself is the addition of these two vectors. Okay. The vectors can be anything, it can be force, acceleration, or anything. The second law is nothing but the parallelogram law. It is nothing but the same thing. See here, this is a vector A and this is a vector B. If these are the two vectors, and suppose this is the tail of the first vector and this is the head of the first vector. Here vector B, this is the tail of the first vector and this is the head of the second vector. Okay. So here what is we are doing? We are connecting their tails and tail. Okay, we are connecting their tails and tail. So this is the first, we can say first side of the parallelogram. This is the second side of the parallelogram. Okay, so here we are just drawing the parallel line to this second line. So I can say it is 2 dash. 2 dash is nothing but the exactly the same parallel line to second line, and this is the 1 dash, which is nothing but the parallel and identical to this line A. Okay, so why we are drawing 2 dash and A dash? Because we need the perfect parallelogram. Okay, so now here we can say the vector going from A to C, which is directed like this, okay, which is coming from the tail of the two vectors and going towards the another point of the parallelogram. So this is nothing but the addition of this A two vectors, that is nothing but A and B. Okay. So what we are doing over here basically in the triangle law and the parallelogram law. In the triangle law we are connecting the head and tail of the vectors, and in the parallelogram law we are connecting their tails. Okay. If you connect head and tail directly, we will get the third side of the triangle as the resultant. And if you connect the tails, okay, then the parallelogram diagonal is nothing but the A plus B. Okay, so because when we connect their tails, we need to draw another two lines here which are parallel to this A and B, and then only we will get this perfect four lines of the parallelogram, and then vector coming from this tail junction, or we can say intersection, tail intersection towards the other side is nothing but the addition of these two vectors. So either you draw with the triangle law or you draw with the parallelogram law. What is the difference is that here we are connecting head and tail of the vectors, and here we are connecting tails of the vectors. When we connect head and tail, third side directly is the addition of the vector, and when we connect tail and tail, we have to draw the two additional lines to make the parallelogram, and then diagonal is nothing but the addition of the two vectors. So here what I will do here, I need to first understand what should be the magnitude of the those two vectors. Here the two vectors are there. The first vector is nothing but the weight of the airliner, and second vector is nothing but the aerodynamic lift force. Okay. The forces are nothing but the vectors. So first force is weight, which is acting on the airliner, and the second force is aerodynamic lift force, which is acting on the airliner. So first force magnitude is given, that is 1.20 into 10 raised to 6. Second force magnitude is given, that is 1.39 into 10 raised to 6 Newton. So this, as I told you before, in the vector this line is telling you the magnitude and arrow is showing you the direction. So this numbers, they have given the numbers. These numbers can be used directly for the calculation, and also for drawing the vector diagram. These numbers are useful. So in the rough calculation you can do here, I can write down like the weight is nothing but the airliner lift is is nothing but 1.39 into 10 raised to 6 divided by the 1.2, that is the weight, 1.2 into 10 raised to 6. Okay, so this 10 raised to 6 and 10 raised to 6 will be cancelled out, and this line you can see approximately. In this calculation will you can get the approximately, the value is coming out to be approximately 1.6. Okay, why we are going to calculate this ratio? Because this ratio is what? This ratio is nothing but 1.6 divided by 1. Okay? So this ratio is nothing but 1.6 divided by 1. So if you consider the weight, this is nothing but the weight. If you consider weight is equal to 1 centimeter, then you should consider the aerodynamic lift equal to 1.6 centimeter. Right? If I consider the weight is equal to 2 centimeter, then I should consider the aerodynamic lift nothing but equal to 3.2 centimeter. So double we will do. Okay. So this ratio is very important. This ratio will tell you what should be the line of that vector force when you draw the vector diagram. Okay. So here if I consider 5 centimeter, you have to multiply this 1.6 into 5 and it will be 8 centimeter. So that way you have to draw the vector diagram. So here roughly I will tell you what is happening here with the help of the triangle law, and then we will draw the diagram over here. So here you can see the weight is acting in the downward direction. Weight is acting in the downward direction like this. Weight is acting in the downward direction. Here I can say this is nothing but the weight, and the aerodynamic lift, okay, which is acting at 30 degree, okay, to the left of the vertical, 30 degree to the left of the vertical. So this itself is a vertical line, that is a line of the weight, but it is in the downward direction, but the airlift is acting upwards in the vertical direction and with the 30 degree angle to the left. So here it is going from this point to this point, and it should be like 30 degree angle to the vertical. Okay. So this vector, this vector is showing you the aerodynamic lift, and this vector is showing you the weight. Here you can see this is a triangle law, because this is the tail of the weight and this is the head of the weight weight vector, and this second aerodynamic lift vector is going from this point to this point. So I can say this is the tail of the second vector, and this is the head of the second vector. Okay, so we are connecting here tail and head, and that's why it is the triangle law. And then this is nothing but the resultant, which is the centripetal force, which is going from the tail of the first vector to the head of the second vector. Okay, so this is the rough thing, and I hope you understood how this is nothing but the triangle law of the vector addition. Okay, so here I just told you, if you connect the head and tail of the two vectors with proper magnitude and direction, the third side itself is the addition of these two vectors. That is nothing but the resultant. So here I will draw the proper diagram. Suppose this is nothing but the weight of the, this is nothing but the, this is the weight vector, and suppose this is a 5 centimeter. We have to draw with proper scale, because this numbers are given and the line is showing me the magnitude. So here I should write down this is nothing but the weight, which is nothing but the weight vector. Okay, now this is the tail. Okay, this is the tail. You shouldn't write down this in the pair diagram. This is the tail and this is nothing but the head. I am just showing here just for your understanding purpose. Now the second vector, which is going from this point towards the 30 degree towards the left. Okay, so it should be automatically how much? If it the first one is a 5 centimeter, this should be automatically the 8 centimeter, and you have to draw this with the proper scale. And here I can write down this is nothing but the This is nothing but the aerodynamic lift force. So this is nothing but we can write down over here, aerodynamic lift force. Okay. So two vectors are drawn here. You have to show the proper arrows. This is the head of the first vector, this is the tail of the first vector. This arrow is the head of the second vector, and this is the tail of the second vector. So we are connecting here the tail and head. Okay, so connecting the tail of the first vector and the head of the second vector is nothing but, you can say, this is nothing but the resultant force, and this resultant force is nothing but the centripetal force. Okay, so here can draw. It should match. Basically, it should properly match. So you should draw it very properly. When you draw with the scale, it will be matching. Here and here, finally, I can write down this is nothing but the resultant force, or you can say the centripetal force. Okay. So addition of these forces is what? It is nothing but the resultant force, and it is directed towards the left, which is nothing but this point. You can say this point is nothing but the center of that imaginary circle. Okay. So here the resultant force or centripetal force is directed towards the left, with the center of the imaginary circle. So what we have drawn here in our diagram is correct. This is towards the left, because addition of these two vectors is giving me the resultant vector to the left. There is nothing with the third side. This you can say the first side of the triangle, weight second side of the triangle, aerodynamic lift, third side of the triangle is nothing but centripetal force. So here we will simply apply the triangle of vector addition. Now the C part of the question, the speed is constant as the airliner flies in the circular path. State and explain why, what is happening to the velocity. So we have learned about the speed and velocity before. Speed is just the magnitude of the motion, and the velocity is nothing but magnitude along with the direction. So see in this circular motion, you can see if it is moving with the constant speed, then we can say the speed is constant. Or if it covers the equal distances with equal interval of time, then we can say it is a constant speed. But what about the velocity? Suppose here the object is over here at this point, so, and suppose object is here at this point, and these 2 points object is moving continuously. So see the velocity is always the tangential. Velocity should be in this direction here. The velocity is always tangential, and if I consider this point, at this point also velocity is always directed towards the along the tangent. So what is happening at every point, the tangent is telling you the direction of velocity. Okay, this tangent is telling you the direction of velocity. If I consider the constant speed, okay, here it is also shown the direction of the velocity. But if you consider if the particle is moving with such that it is covering the equal arcs, okay, that means equal distances in equal interval of time, we can say the speed is constant. Speed is constant, but though the speed is constant, the direction of velocity is always changing because it is always tangential, and that's why velocity is not constant, because velocity is speed along with direction. Though the speed is constant, but since the direction is changing, we must say the velocity is also changing. So here, so we can write down, since the direction of the motion of airliner is changing, velocity, and say the velocity is changing, but the speed remains constant. The speed is nothing but the scalar quantity, but velocity is a vector quantity. So though the speed of the airliner is constant, since its direction of motion is changing continuously, we can say the velocity is changing. Okay. So I hope you understood this concept between the speed and velocity. It is changing because it is nothing but the vector quantity and it requires the direction as well. So here we are ending our structured problems.